All right, so for this question here, we've got a hawk that is flying in a horizontal arc. And so it's traveling around in a circle, and we'll just kind of draw a quick picture. Some sort of circular path, kind of like this, and it's moving perpendicular to, or along that path, so tangent to the path or parallel to the path at each point as it's moving around. And to start off with, we're looking for what is its centripetal acceleration. And so for this, we've got that circular motion, requires a force, and the centripetal acceleration, A sub c, is always equal to exactly v(t) squared over r. So it's equal to the tangent velocity divided by r, and it has to be exactly equal to this. So for this one, it's just going to be 4.1 meters per second over 11.6 meters. And so this is squared, so you wind up with units of meters squared per second squared divided by meters, and you get meters per second squared. So for this question, we get here 4.1 squared divided by 1.6, and we get that the answer is 10.5, 10.5 meters per second squared, which is, a little above the gravitational acceleration. So 10.5 meters per second squared, 1.5 meters per second squared. I typed this in wrong. 4.1 squared divided by 11.6. Sometimes you need to tell your calculator what to do correctly, and so we get 1.45, which is the same answer that we got right there. Wonderful. Now, moving on, we're going to continue to fly along the same horizontal arc, so same radius. R is still equal to 11.6 meters this time, but this time it's speeding up. This bird is speeding up, and that's the thing that we want to notice here, is that it's got an acceleration not only in this direction, that was the direction of A sub c, but it's also going to have an acceleration in this direction along its path. We call it A sub t, or like the tangential acceleration, or the acceleration that causes it to change speed. So this is the thing, when an object is moving along in a certain direction, let's say it's moving this way, if this is our direction of velocity for some object, as it's moving along that direction. If it accelerates like this, if we have an acceleration vector in the direction it's moving, it's going to speed up. If we have an acceleration vector in the opposite direction that it's moving, it's going to slow down. And if we have an acceleration vector perpendicular to the direction it's moving, it's going to turn without changing speed. And so this is the idea here, is that this centripetal acceleration that we had up above tells us how much it's turning, and this tangential acceleration tells us how much it's speeding up. So we've got two different accelerations in this case. First, we have the same acceleration that we found earlier on. This one right up here, A sub c, which is this value. We're going to use that again and also consider the tangential acceleration, how it's speeding up or slowing down as it's moving. So we're going to use this acceleration here to figure out the total magnitude of the acceleration. So here we've got along the direction it's moving, A sub t, that's going to be equal to 1.1 meters per second squared. And we're going to have a perpendicular acceleration equal to, in this case for this problem, 1.45 meters per second squared. And what we're trying to figure out is, what about the exact magnitude of this? And so the magnitude here, we're going to go ahead and use Pythagorean Theorem, a squared plus b squared equals c squared, to figure out what this value is for the magnitude. I'm not going to walk through that right here, but if you want to look at my answer, this is what I've got. So we're adding them up vector style, and then to figure out the direction, we're going to use an inverse tangent to get this answer. So if you want to check with my numbers to see if you get it right, you can go ahead and take a look at that. But basically, you're going to get this idea that there's the tangential component, the centripetal component, and then together that makes some angle over here, and it wants you to find the angle measured from the center of the circle. So if it was going like this, it would be that angle right there. Hopefully this gets you there. Good luck with this one.